All right, good afternoon or good morning to those of you out west, and we already have somebody from Hawaii who weighed in. This is Zach Zaharowitz, Vice President of Applications at the Lighting Quotient, with Paul Ford, our Vice President of Product Design. And today we're going to present the new style S112 linear LED product. Before we get started, I wanted to mention two things. First, we're going to stay on camera. If you'd like to have us minimized in the corner of your screen as we go through the PowerPoint, feel free to do so. However, at the end of the presentation, we are going to show you the sample kit and kind of go full screen, full camera. So you definitely want to have the video available to you at that point. And also, if you have any questions, Zoom has the Q&A box, which enables you to type in questions, or under More, there is chat. However, we don't have a third person able right now to be monitoring the chat live in real time. So I would suggest if you do think of a question, use the Q&A. Please type that information in, and at the end of the presentation, we'll get to those questions. So with that, I'm going to turn things over to Paul.
Okay, thanks, Zach. This is Paul Ford. I'm the VP of Product Design here at the Lighting Quotient, and I'm excited to talk to you today about the introduction of the S112 linear LED product. I'm going to start off by showing you our portfolio of LED product families. You can find this on our homepage. Down at the bottom, there are some boxes. One of them says "That to This." At the end of the year, we're going to discontinue fluorescent, metal halide, and halogen, and so we'll be all LED. This helps you to navigate through all of the LED product lines on the front. If you hover over and actually click on one of these in the live PDF, it will open up the spec sheet for you directly. On the back of this sheet is a "That to This," meaning what we were selling in fluorescent or metal halide. We give you the suggested LED equivalent. So that is on the website now. And let's get right to the 112. It's our new Xtra-Small Linear LED Wallwasher, and it's very small in profile. I'm going to show you the cell sheet, which is on the screen right now. This is the front of the cell sheet, which all of this documentation that we're going to show you is on the website now, and it is accessible. And on the back of the cell sheet, we have the features and benefits, some detailed photographs, as well as the candela curve. I'll just take you through the features and benefits now. It is an indoor linear architectural wall washer with an asymmetric distribution. Very small in size. It's 1 1/8 in diameter for the housing. We are using proprietary refractive lens technology, which was originally developed for the S430 series. And it does deliver a uniform wash of light, maximizing light to the target surface, minimizing spill light. It's an extruded aluminum housing. We offer lengths up to 6 feet long. We can do longer lengths. Just consult factory so that we can discuss the project and the orientation and the application with you before we do. We developed new miniature hubs. They're very similar to the previous design, but they're much smaller. They do offer fully adjustable and lockable aiming as well. The extrusion itself is an aluminum extrusion, and it does have an integrated visor, which shields lens brightness from normal viewing angles when you're standing behind the fixture looking up at it while it's wall washing. We also do offer an optional cross baffle, so if you have views along the length, you can opt for the cross baffle. Even if you originally ordered it without the baffle, you can order it afterwards and install it in the field. We offer pendant from the ceiling mounting. We offer pendant and cable, or it could be wall mounted with a cantilever. In choice of color temperature from 2700 through 4000 in 80 CRI. We do offer other color temperatures and CRIs upon request. It's a very high efficacy for. It goes up to 122 lumens per watt at the coolest color temperature, lowest drive current. And even at 3000 Kelvin at the highest drive current, we're at 100 lumens per watt. Delivered lumens can be as high as 1560 lumens per foot, and that is at the coolest color temperature and highest drive current. It has great lumen maintenance. We maintain over 85% of initial light output beyond 60,000 hours. The drivers are available 120 through 277 volt input and also 347 volt input for Canada. It's all aluminum and stainless steel construction, so it's ideal for use in MRIs where the driver would be remote mounted outside of the MRI suite. It is CSA certified for suitable for damp locations, and we do have US and foreign patents pending. The new refractive optics, as I said before, were developed for the S430 series. It takes the light from an LED and redirects it into or reshapes it into a asymmetric distribution, ideal for lighting surfaces from one edge. And the optic itself, while it looks pretty large in this slide, is really only about the size of a quarter. This is the front of the cut sheet, and as per usual, it has the line drawings, the dimensions, specifications, performance in the corner showing the thumbnail of the candle power curve. You can zoom in quickly and just see the cross section of the optical assembly, details for the pendant and cantilever mountings. And there's a chart on the bottom right, which you can see 2 foot, 3 foot through 6 foot. The 4, 5, and 6 foot are exactly 4, 5, and 6 feet center to center of hub, which is helpful for to coordinate with architectural details. On the back of the sheet, we have the style and the style number. We have the length and light output chart, and this lists all of the lengths 2 foot through 6 foot in each of the 3 drive currents that we offer, 175 milliamp, 350, and 700. And it lists the wattage as well as the lumen output. Now, the lumen output in this chart is based on 3000 Kelvin 80 CRI. If you want to see what other choices would produce, click here. It'll open up a scaled performance chart, and you can look up the length and light output based on color, temperature, drive current, etc. It's all accessible from the PDF itself. We have one mounting code. It's X, which is the same mounting code that you would use for a ceiling mounted pendant or a ceiling mounted cable. Aircraft cable. You can see that this does have, because it's a slightly asymmetric load, there is an adjustment on the cable that allows you to aim it and then slide it so that it hangs straight. And then we have cantilever mounting for the wall mounting to wall wash. Finishes are available in our standard semi-gloss white, semi-gloss black. We also offer the RAL colors that you see here, as well as if you have a sample chip, you can send it in to us. We'll get it computer matched as well. Voltage driver options are available in dimming and non-dimming for 120 through 277 and 347. There's a link here as well called MA-1303, which opens up another PDF where you can have access to more information such as remote distance, starting temperature, and you can really even drill down and click directly on one of the cut sheets. It'll open up and give you more specifications for the driver itself. So that's very helpful. Options include, we have a baffle option, as I mentioned before, for lengthwise shielding. We do have an MRI option, which is just some small changes to the hardware for non-ferrous materials to go into the MRI suite itself. Destination requirement code, 0 for US and J for Canada. They're both CSA certified for damp locations. Color temperatures, as I mentioned before, 2700 through 4000 Kelvin at 80 CRI, but we can offer other options as well. Dimming is available in 0 to 10 analog. We have 3 types of Lutron dimming for 2-wire, 3-wire, or Echo system. We have 2 versions of Elda LED, which dim down to 0.1%. There's a 0 to 10 version as well as a Dolly version, and we have done DMX as well. Up in the top right, you'll see mounting hangers, and if you click on those, it'll open up another PDF that gives you much more detail into the assembly construction specifications of the hangers themselves. This is for the cantilever. This one's for the pendant. They look very similar, but they're each showing different aspects of it. This is for the cable. So those are all accessible from the back of the catalog page just by clicking on those links. Accessories include a MRI filter for MRI jobs, and then we also have extension cords. The fixture itself comes with a 10-foot cord, but if you need to go further, you have the extension. Now we get into the construction of the fixture and the accessories. We did develop a new miniature junction box. It's about half the size of the standard as far as the diameter of the canopy. So on the right, you can see a standard junction box and a typical 5-inch diameter canopy. We created a new junction box that works well with a 3-inch diameter canopy. And you can see the difference in the pipe itself is going to be smaller as well. This is kind of zoomed in on the front and the back of the junction box. It's a 2-inch by 2-inch rough opening. And as you pop it through, and I'll have a small short video that should start any second now. And it'll show it disassembling with the canopy coming off and the crossbar, the cantilever arm with a saddle bracket. Now the junction box goes in through the 2x2 hole. The bracket on the back pulls against the back of the sheetrock or the with backing. I'll play it again real quick just so you can see it if you missed it. So this is just showing the disassembly of it, and then it'll go back together again. So that does show the rough opening is 2x2. It's a toggle bracket that pulls into the back of the wall, and then the canopy finally covers it up. We had to, for UL requirements, we had to load the cantilever arm out at 18 inches at 4 times the weight of the largest fixture we would ever use on it. So in this case, it was loaded up pretty well. You can see it did flex the cantilever arm. Once the weight was removed, the arm sprung back to its normal position. It does deflect, but that's part of the test, and it had to be subjected to this weight for over an hour. There's also a leveling feature on this cantilever, which is very helpful when the wall is not straight. It can move the arm up and down slightly so that you can level the entire row. We also developed a new extrusion that's used in between the fixtures, so it blocks the light between fixtures in a continuous row. It eliminates the interruptions and gives you that continuous look. So that's an extrusion that slides on, and it helps also to align the row when you have long fixtures in a row. You can also use that at the end if it's desired, if that's a desirable look. I'm going to hand it over to Zach, and he's going to take you through the website.
All right, we're going to touch on the website now. I'll turn it back to Paul, who's going to go through some performance, and we'll wrap up talking applications in the sample kit. As far as finding the product information, as Paul mentioned, all this information is already on the website. Once you click the products button, you could either do find a product, which takes you to sort of more of the full gallery. What we're going to demonstrate here is going to the quick finder, and as a new product, typing in the style, we're discussing S112. And then at the right side, you see all your choices pick up as far as other resources that are available. The data sheet would be the black and white cut sheet that Paul already covered, so we're not going to do that again. The product fact sheet really consists of 4 items currently. The first one being the 2-page color cell sheet, which we did illustrate. So if somebody wants some color photography or that type of presentation rather than all the specs, that is available. There's also the scaled performance table. As Paul mentioned, you can link to this directly from the cut sheet, but we thought it was helpful to have another link under the product section that if somebody came in here first looking for that kind of information, they would again find it. The labeling from the lighting facts label is shown here, although that's included on the cut sheet. Somebody wanted to look into that in greater detail. It's available as a separate file. And then finally, the TM30 reports. Since IES and DOE did their presentations announcing this as possibly another way of quantifying or discussing color, we've been trying to support it in terms of putting our information on the website for your designers to reference. If you open that zip file, you're actually presented with 4 choices, those corresponding to the 4 main color temperatures that we're offering. So for purposes of this discussion, we picked as an example the 3000 Kelvin, 80 CRI. And the spreadsheet IES created really generates several pages of summary information. Everything we've included in these PDFs amounts to 7 pages. We've just picked 4 of them here to highlight a few items. If you remember, the traditional color rendering index was based on comparing your tested source to a reference source of the same color temperature. So in much the same way, TM30 repeats that information of saying, Here's your 3000 Kelvin black body reference source and its spectral power distribution, and then overlaying the tested source, in this case, a 3000K LED. Beneath that, you see what's the closest build up to a new CRI, what they call R sub F, or the fidelity metric. You may also recall the traditional CRI was based on 8 colors, although there were also colors 9 through 14. The scoring was based on 8 pastel-like colors, and how faithfully or similarly the tested source replicated those colors compared to the reference source. Well, the same thing is going on here in a fashion, except that TM30 includes 99 colors. For purposes of this particular chart, they've summarized those 99 colors as 16 hue bins. So you see everything from a red through red-orange, down through your blues and your violets. And in any case you see a bar not touching 100, that's meaning there's some variation from how this source is rendering those colors in a hue bin versus the 3000K reference source. What it doesn't tell you is exactly how is it different. And that's related to the chart below, which is gamut, which is a measure of saturation, meaning are colors here being undersaturated or oversaturated compared to this reference source. So in an example, as what you see here at the far left, where you see red dipping below the 0 datum line, that's indicating to you, compared to the reference source, red is being somewhat undersaturated by comparison. Or as an opposite example, in terms of these blues, you see the bar creeping above the 0 datum line. That's telling you this source is tending to saturate those colors compared to the reference source. The bullseye diagram to the right of that is just a different way of depicting that information. The theory here is if you see a color creep inside of the circle like these reds, that's another indication that they're being somewhat undersaturated compared to the reference source. Where something creeps outside of the circle like these blues, that's telling you they're being more saturated compared to the reference source. Moving on to the next page, some of this summary information is similar, but it's giving you the new R sub F, or fidelity metric, being 81. It's summarizing that gamut metric, so something less than 100 is sort of suggesting on average, most of the colors are being a little bit undersaturated compared to the reference source. And if you're interested, it does give you the traditional CIE color rendering index. In this example, they happen to be the same, but I'll tell you in many instances, you'll see some differences where the new fidelity metric may be a few points higher or lower than what the traditional CRI would have been. Here you see all 99 colors, and the thing that's a bit subtle here is this depiction is meant to show you that in each cell, the left-hand side is trying to illustrate how the reference source would have depicted or rendered that color, whereas the right-hand side of the same cell is showing you how this tested source would render that color. And this super bar graph is showing all 99 colors in that scale up to 100 if you wanted to see each and every green, each and every red, blue, or violet. Moving on from that information for ITL files, if somebody wants to dig into the original report information rather than just obtaining an IES file, we have both the photometric report showing zonal lumens, candle power distribution, and candela curve, as well as the spectral power distribution information that we obtained. However, for IES files, if you or your own staff is doing calculations or your designers, we have a wealth of IES files to save legwork in dealing with all the selections you might potentially make. And the way these are organized, you have the 3 primary drive currents. We can certainly program to other drive currents, input wattages, and lumen outputs. But the 3 standards that we're offering are 175 milliamp, 350, and 700. And then for each of those 3 super categories, your color temperature selection. So in this particular example, we went with the low drive current, 2700 Kelvin. And when you open that zip file, you're again presented with all 5 standard lengths. So if you're doing an odd row length of 27 feet as wall lighting in one of your models, and you want to comprise that row, you don't have to wing it and create your own 5-footer or 4-footer. All those are available as distinct files that you can bring in and relate to the appropriate fixture length. The CAD file link really gives you two choices. There's a BIM zip, which gives you a Revit file. This is a face-based S112 object that you can place either into your architectural package, if that's what you have, or an MEP consulting package. So in either case, you can place these relative to a ceiling or wall plane appropriately. However, if all you really need for your specifier is a 2D CAD file, that's also available. While there's some isometric views here, this is really 2D CAD information. So whether they're just trying to create a detail for their drawing set, or they'd like to create their own Revit object and just keep it as simple as possible, they can possibly choose this DWG selection. Under installation files, there's a wealth of information that frequently were asked for by designers as much as installing contractors. So there are a sequence of files that take you through everything from the cantilever mounts to the pendant mounts and the aircraft cable mounts. There's a sheet illustrating that the mounting centers are identical for each of those three mountings, but giving that as separate information on its own sheet. This is a very helpful sheet that walks you through what fixture lengths you're using, be there 2, 3, 4, or 5-footers, 6-footers, which drive current are you selecting, and also which driver selection. So if you're curious as to, for what you're specifying or your customer is specifying, how many cord whips will be exiting that row? Where will it be exiting? All that is spelled out in this nice summary. And in addition, there's a separate sheet dedicated to the two driver sizes or driver box sizes we use for the various standard driver selections. There's also a sheet entitled Disassembly and Recycling. So as this becomes more prevalent and more common, you can reference the hyperlink and access a map that will tell you in different parts of the US where there are recycling centers capable of dealing with these materials. Finally, the Configure It option allows you to do customized cut sheets. As agents, and you're our audience today, you would quite likely come in and use your agency login and be looking at the rep portal, where you'd be presented with the same information side by side with the pricing information. However, even a specifier can go in and access Configure It. This will guide them through the things, the choices they need to make, which then improves the odds of ending up with a correct and complete catalog number. Once you go through each of the major areas Paul already covered on the cut sheet, this cut sheet selection button becomes live. You can enter specific notes. In this case, it says mount under soffit. You may have a project where you want to flag in schematic design that a custom paint chip is going to be required later during the DD or CD phase. Whatever notes you want to enter, those are available to you. Once you click Cut Sheet, you'll be asked if you'd like to enter a project name and type designation. And if you do, the generated cut sheet will include everything from the configurator, any special notes you generated, as well as the type designations. And those will also repeat on the back side of the same cut sheet. So all that information will be complete. With that, I'm going to turn it back to Paul, who's going to go through some of the background performance information relative to this product.
On all of our fixtures, we use third-party test facilities. In this case, it's ITL Boulder. Sometimes we use UL verification services. But in this case, it was ITL for our 3-foot fixture. It's 3,000 Kelvin, and it was running at 700 milliamp driver. And in this, on the second page, it'll give you the candela distribution in a tabular form, as well as a thumbnail of the curve itself. It displays the total lumens delivered for this fixture, as well as the efficacy, in this case, 100 lumens per watt. There's also part of this test, this is the LM79 test, which is part of it is photometry. The other part is this, which is the color measurements or spectro radiometric tests, where they will give you the correlated color temperature, in this case 3085, as well as the IES or the CIE color rendering index of 84. It also shows you the spectral power distribution curve, which is also helpful because it gives you an idea of where it's has blues and reds, and it can also be used in the TM30 as well. LM80 data is testing that's done on the chip itself. In this case, it's a Nichia NFSL 757 GB1, which is a mid-power chip, and this is a data set for that testing. They test several chips at different currents and different temperatures for a period of at least 6,000 hours. In this case, the testing was done up through 10,000 hours, and they'll measure the VF, or the forward voltage. They'll measure the color points as well as the light output. This chart is showing the light output over the 10,000 hours at a temperature of 55 Celsius at 150 milliamp. And you can see that after 10,000 hours, it only decreased to 97.7. So this information is used, and I'll show you in a bit, on the TM21. The ISTMT is a test that is done also by, in this case, ITL, where we send the fixture out for photometric test. They will also put thermocouples on the LEDs and the driver and take measurements after it has reached steady state temperature. And in this case, the hottest LED was 53.5 Celsius. Now, with this information and the LM80 data from the chip manufacturer, we can extrapolate the time at which it reaches 85% light output in this case. So on the right, you'll see all the LM80 data, and then we put in our in situ temperature for the LED, in this case 53.5, and then we can calculate or estimate how many hours will it take to get to 85% light output, which is shown here. The reported value is greater than 60,000 hours. Now, the reason it says greater than 60,000 hours is that per TM21, you cannot extrapolate beyond 6 times what you've actually measured. So in this case, it's 10,000 hours of actual test time, so 60,000 hours is the max. So keep that in mind if you hear claims of 100,000, 200,000 hours. They would really need a lot of LM80 test hours to back that up, so keep that in mind. I'm going to pass it back to Zach. He's going to go through some applications.
It's probably not surprising at this point to say that we see the primary use of the S112 as a linear wall washer, and probably in most instances as a continuous run wall washer. Over the years, those of you who have been our agents have probably heard us say frequently, when doing wall washing, we like to look at what the wall height is, and we frequently or most typically look for a setback distance that's about a quarter of that wall height, and we'll often add the caveat, but not less than 30 inches or 36 inches, depending on the source. However, linear and continuous is different. Think of it this way, that the reason we've always used continuous linear sources for cove lighting at a closer distance to a ceiling is because they are different. They do allow you to cheat closer. So typically with our linear continuous row sources, we'll say we'd like to have 1/8 of that wall height as a setback distance, but perhaps not less than 12 inches or 18 inches. And that's indicative of what you see here at Jacksonville Library. Yes, this is an older F115 installation, but I just wanted to point out where you think continuous and linear. In this case, the issue of staying closer to the wall was relative to a few things. It was difficult to ceiling mount given the overall nature of the space, but there was also a concern that as you walk through these large portals into the map room, to keep the wall washers out of a position where it would be easy to look up at this grand space and look into them. So the solution that therefore had in mind staying continuous and linear and closer to the wall. Here's a different situation. This is certainly not a continuous run, but for 360 State Street, there was this organization where they created a linear picture rail. In this particular shot, they're very small pieces exhibited, but they change this out frequently. Sometimes they're large works, and they were looking for a linear piece that would kind of relate to that linear picture rail element. So you can also see the 112 in a use such as this. And more recently, using our S101 LED remote driver, this is a display pinup area at University of New Haven. These large wall areas are located between design studios. You see a tall ceiling, exposed concrete. There are windows shared between corridor and classrooms. You get the hint of a pendant that occupies the center of the space. So for a lot of reasons, the architect knew that they wanted to be in a position that was just above the pinup surface, fairly close to the wall, and once again, going linear and continuous really was a good fit. It's interesting how quickly the size, scale, and form factor has changed through the variety of just those three projects, which aren't separated by that many years. At the far left, you see the F115 from Jacksonville, which was a remote ballast T5 product. 360 State Street used a smaller reflector, again with T5 and an integral ballast. And then you compare its size to the 2-inch diameter remote driver S101. And today we're talking about the 112 remote driver at 1 1/8 inch diameter. So again, a very rapid evolution in scale and form factor. In terms of lumen output, what we're looking at here is sort of a side-by-side of those same sources, looking at 4-foot fixtures, 3,000 Kelvin color temperature, and in the case of the traditional fluorescents, these are adjusted to be delivered lumens. These aren't lamp lumens. What we said when we first came out with the S101 and its related S102, which was a smooth extrusion, we would often say, you know, if you go with the 350 milliamp version, you're going to have a delivered lumen outcome that's going to be like our traditional 28-watt T5 and a similar input wattage. If you were thinking of an application where you used to use T5HO, then you're going to want to select 700 milliamp. With the 112, we're now getting the benefit of a huge efficacy boost from the mid-power chips, so much so that that lower 175 milliamp drive current is now very close to what that T5, 28-watt T5, or our 350 milliamp S101 was at half the input wattage. The 350 milliamp is equivalent to the 700 milliamp S101 or these T5HOs. And if you go 700 milliamp, you have a serious lumen package that, whether it's a taller wall surface or just a wall surface that perhaps has a dark color scheme, but it's a feature wall, gives you a really wide latitude in terms of lumen packages depending on what the application is. And my enter doesn't want to go. I'll try to, yeah.
Click on it.
Sorry. As much as we talked about wall washing, the 112 may have other applications for you, and I just wanted to point out, don't necessarily rule it out for ceiling washing. This is a rendering that was presented to us of a feature wood ceiling. Off to the left, there are a series of private offices with some glass walls and a different ceiling system, and in between there was an open pocket where the designer wanted to suspend aircraft cable or pennant stems and use a very minimal form to get some light onto the wood ceiling. And they gravitated toward the 112. Certainly, this visor we're using as a wall washer to keep you from seeing the lens when you're standing behind and below the unit doesn't necessarily cover or conceal all the lens in every uplighting application. But in this case, it was a nice fit, and it did give them that minimal form they were looking for. So don't necessarily rule it out for uplighting applications. If you go under the resources button and click through that, there are 2 new live links for indoor and outdoor application guidelines, and those bring up renewed versions of this traditional information we used to have. So if you go into that table, you will see the 112, excuse me, I double-clicked. You'll see the 112 listed under the linear continuous run sources, and as I mentioned, the suggestion of probably wanting to be 1/8 of that wall height as a setback distance, but not less than 12 to 18 inches. In terms of the sample kit, those of you who already have an S101, 102 kit will be getting, this is what your kit looks like with a carry bag. You'll be getting a new foam insert with the new components. You can use the shipping box for this material to return your old S101 insert, reusing the old carry bag with the new kit. Any agents who don't currently have an S101 kit will be getting everything, meaning this insert, the S112, and a new carry bag. In terms of how to perhaps demonstrate the sample, we're going to open up, stop the screen share and go to a short video we shot. The samples you'll receive are 3-foot samples. They include a 1-foot length of the snap-on baffle, so it's just a very simple way of showing how it looks with and without the baffle. Once we get this open, I'll make a few other comments. Wait, we have to go back and make sure it's shared.
Share.
The first point you'll see when the video starts is we recommend you make your low voltage connection to the remote driver box first. Our whips are provided with Wago connectors that plug in on a real installation, so to speak, that has a clip that keeps the cord from then pulling out easily. In this case, for your samples, we disable that clip so they're very easy to plug in and unplug. After you plug into the box, plug into the power source. Would suggest perhaps first holding the fixture 18 inches back from the wall so it doesn't wash the wall. We like to make the point there are a lot of small form factors out there that do a miserable job of wall washing. Then rotate the fixture so it lights down the wall. And if you start with the dimmer closer to the low end rather than the high end, that gives you the opportunity to ramp it up. Just to make that point for taller walls or darker walls or feature walls, you do have a wide range of lumen packages available. Often you'll have a designer say, hold it up against the wall so I can demonstrate the candle power curve. And we don't have the same latitude as the human eye here, but this gives you the idea of showing them the visor providing the shielding from the backside and where max candle power is oriented in its typical wall washing application. Back to that issue of using the dimmer we're provided on the driver box. It's just a nice way of saying if you're on a very energy conscious project, you can perhaps use that low drive current, be at 3.6 watts per foot, and still be getting 380 to 440 lumens per foot. As you ramp up, you're at about 7.2 watts per lineal foot at the 350 milliamp drive current, now up to 700 to 800 lumens per foot. And at 700 milliamp, you're about 14.5 watts per foot and generating anywhere from 1,300 to 1,500 lumens per foot.
And I should have mentioned earlier that pretty much all the drivers we're using now are programmable. So even though we offer 175, 350, 700, we could actually tune it to whatever you need, whether it be hitting a target foot candle level or meeting a watts per foot criteria. That's easy to do.
So the final thing we wanted to show was physically the sample kit and a few of the parts.
So this is the insert. You'll see that there's a 3-foot fixture that comes with a 10-foot whip so that you can plug it in and still hold it over your head. It has a 1-foot baffle segment, which actually can be slid to any position that you want. The fixture comes with hubs at each end. I'll show you a little more detail on that. The driver box itself has the quick connect plug here, and then it has the dimmer knob here, so you can adjust the light output. It has a short cord just to make it manageable, but we do provide you with a 12-foot extension cord.
And if you do have the dimmer at the full bright level, that's equivalent to the 700 milliamp driver.
So the lens itself is actually an extruded polycarbonate lens. And it has some diffusion. It has just the right amount of diffusion to create a smooth, smooth distribution, gets rid of all the striations. This is a kind of a quick view into the end of it. You can see the aluminum extrusion. It has die-cast aluminum end plates, which envelop the extrusion itself. You have machined hubs. These are aluminum machined hubs with set screws to lock the aiming. The other feature I wanted to show, we have a little mock-up of the junction box with the smaller stem and the smaller canopy. You can see the junction box with the crossbar. It's a much smaller box than a standard box. It does allow you to move the stem up and down slightly. A little bit of movement here actually ends up with a lot of movement out at the end of the stem. And then the canopy slides on. There's a slip ring which centers it and locks it in place. And then just to show you the back side, just looking at what it would look like behind the wall where you have your clamp here. And it's very rugged. We've saw the photo of the load test that we did, and it's worked out very well.
Okay, as I said, we had Hawaii saying hello earlier. We had one other question. How far away can you install the remote driver? When Paul showed that there was that live link to the driver information page right on the back of the cut sheet, one segment of that page gives you maximum remote wiring distances for each of our standard driver selections. In most cases, there are also notes saying if you use a certain gauge wire. For instance, the Wago connectors we use on these whips will work with number 18 or number 16, and you'll see on those charts in some cases if you need to go a bit further using your own number 16 wire will let you go further. But it's a handy reference as far as answering that question when you have a specifier. Just click through to the cut sheet to that page, and if they're thinking standard 0 to 10 volt, use that.
And I just happen to remember from yesterday that it was, had to look this up, it was the 0 to 10 drivers can go 112 feet with a number 18 gauge. So, but all of that is listed on the chart that Zach just mentioned.
We had also a question about the cantilever length. The standard 18-inch length is probably going to get you through on those walls that are 8 feet to 10 feet high, with the upper end of that range being somewhat similar to that University of New Haven project. You're absolutely right. The lighter weight of the fixture helps. However, we've also gone lighter and more precious on the support.
We do catalog up to 24 inches now for the cantilever.
Oh, okay. I thought we still topped out at 18 inches. What I will say, though, and admittedly this gets into different territory, but if you have a very unique situation, and these come up fairly frequently, somebody says, I have a 16-foot high wall, I can't pendant or cable mount, but I need an arm, or I have a 12-foot wall. We will get asked, can you do 30 inches, 3 feet? And there are other options where we either look at modifying what the mounting is and doing something differently. I'm sure on some past jobs you've seen us use a secondary support cable. So engage us, and Carl Luke from our customs department, as well as our applications group, can help you vet those requests. Do we have a smaller driver box than the one delivered with the sample case? No. There are some of the drivers we use are perhaps small enough to allow a slightly smaller box, but it's surprising for many of the case configurations we do use, we can't really save that much. So we've continued to stay with this as the smaller box, and then what we call the larger box is slightly longer, but slightly narrower in cross-section. That's not to say, though, if you get into a project where you're talking about a specific driver or really need to pinch an inch, that you couldn't call us and say, would it be possible to do a slightly different box? So again, anything of a sufficient quantity, yeah, we can look at that, and if we need to do a different box, that's a possibility. So with that, we thank you for attending the webinar this afternoon. Hopefully you find lots of wonderful applications for the 112. If any of you have questions following the presentation, reach out to either of us. Paul's email is pford@thelightingquotient.com, and mine is Zach, Z-A-C-H, @thelightingquotient. Thank you again.
Thank you.